I think it's like we can start again. So the next speaker is Dunja Duran from Fondazione Carlo Besta in Milano, Italy. And she will be talking about using MEG in MRI negative epilepsy. Thank you, Dunja. Please go ahead.
Okay. Hi all, I'm Dunja Duran. I'm working at Carlo Besta and I'm belonging to Laboratory of Magnetoencephalography, and I will talk about I will be more clinical than you, so I will talk about non-invasive methods in MRI negative epilepsy. So in this case, we don't have a lesion that can lead us to what we resect, and we need a lot of help to find out. There are, of course, a lot of studies that try to find the best method, the best options to find the best method useful to find the solution and to find try to find a method to find the optimal pipeline for find the optimal outcome of the patients, but of course it's not that easy. So there are, of course, a lot of combined methods we try with PET, magnetoencephalography, fMRI, and it's a long story, but it's something up to on the table. We try to find using 4 methods, separate methods, non-invasive, in this case, very well used PET, MIG, AKDAG, and EGFMRI to find out what is the best, or in the case, what combinations can be useful to find out the best outcome of all the patients considered. We are starting for the worst patients, so no MRI lesion available. And so they are all underwent the stereology to find out what is the probable easy onset. Of course, the first thing that we consider the concordance between the resective plane, and the secondly, we had, of course, the follow-up of all the patients. So we could also studied the concordance in terms of outcome, also concordant outcome of the patients. We collaborated, we did this project with this in Desire, so we spent a lot of 4 and 5 years doing it. So we had 41 patients, but not all had all the techniques, as you see. We had a lot of 41 for the MEG and PET, most of all, but not all for the EGFMRI. So at least at the end, not all the techniques could be included, or 41 for the patients. As you can see, in this case, I'm showing what we studied for each of the techniques. So for the MAG and AKDAG, we just studied the localizations of the interictal epileptic discharges, or average spikes, or localizations of the rhythms abnormalities. For the EGFMRI, we do use the IAD timing as a recursors, and to try to find the same, so localizations of the spikes. For the PET, we relied on the clinicians who told us the abnormalities on the metabolization of the of the regions are abnormal. And we used, of course, the desiccant Killarney for the indication at the end of those regions, so just to know what we are and what we are excluding in the resection planning. So in order to calculate the concordance of all the categories, we used we combined the single and use also the coupled adding every time another techniques, and trying to calculate all the concordance. So in this case, we calculate for one methods, and we tried more and more adding the concordance, and finally, if all concordant in the surgical plan, that should be the best option. That was our, in our mind, the best solution. For the patients, of course, we had various patients, so all the logs included, not just temporal patients, with the very large, of course, probable resection zones, and very small, so they were very various. And so we decided in the second place to use also the subgroup of 20 subjects with which had more than one lobe involved in the resection, and those are considered more problematic because, of course, you are removing more brain than just a singular lobe, so singular small resection. In this case, you can see just, I will show you just one small short example of a concordance in this place of the MEG and AG results. It is included in this place. It is included in the resection, so it is considered concordant. This is of one subsample of the patients. So for each technique, we consider the concordance of the results to the resection, non-concordance, and if they have just one lobe involved, more lobe involved, and of course, in this case, sometimes we didn't have, not all the techniques were available, and sometimes we could not find the best solution. Of course, in the case of multifocal solution, they were considered not concordant. After we studied the concordance with the resection, we tried to find combine this concordance with the outcome of the patients, at least 1 year after. And we decided to calculate this for very classical quantities. So in case of, we had good concordance between the non-invasive techniques and the good outcome. In this case, we had the positive, true positive. The false positive we have when we had, of course, the good concordance but poor outcome. The true negative, the discordance between the non-invasive techniques and the poor outcome. And finally, we have the discordance between all the techniques, or between the single techniques and strategy, but we have a good outcome. From starting from that, we calculated also the sensitivity, specificity, so the classical measure, and in particular, we try to find accuracy, the best for all the combinations. These are the first, consider the first results. So of course, in case of all operated patients, we had, in this case, for each technique, we had the concordance with the strategy. So in terms, of course, in resection, and we see that the more techniques were involved, the concordance is lower, of course, because you had to have the concordance between more techniques. There can be considered so the different phenomena. So in terms of localization, it is not the best choice, and to consider just in terms of concordance with the preoperative, considering all the patients. If you see the sensitivity, specificity in all considering all the patients, you can see that they are all quite the same, considering the single techniques, and they are poor when you trying to use all the techniques and including in the evaluation. On the other side, if you consider the more problematic, so multi-lobar subgroup of the patients, you can see that there is an improvement. So you can see that in particular, you can see that in MIG, it is good sensitivity. It is they all increase in the accuracy if you use all the techniques. And this means that in this case, there is an improvement in and they can be very useful to use more techniques than just one, to have a good outcome and to have a useful information in this case. I forgot to tell you that considering all the patient, it was something that was that PET has a good sensitivity and EGF MRI has a good specificity in considering the signal techniques and all the patients. So MAG and ACAD-EG showed the similar, so not very high sensitivity when considering all, but they all improved when we considered this subgroup of patients. And this is an example of when combining three techniques. So on the left, we can see when we use all the patients and not considering the multilobar, so this particular category. We don't have any improvement considering more techniques, and we just see that PET help in including PET and EG fMRI can improve the specificity, but we don't have any, how can I say, the accuracy stays the same in all the cases. So we cannot say that it can be useful to use more and more techniques than just a couple that they already said. In case of multilobar patients, we can see on the other side that in all the cases we have an improvement in the accuracy, and we can see that we can see that this summarize what we already said, that of course including more than just one techniques can be in terms of concordance. It's not useful for considering all the patient, but considering also the subgroup in terms of concordance with surgical planning. What is useful and is in the second group, considering the accuracy that increases, and specifically including this is due in case of discordant results that can be helpful to decide to not to undergo this subsegment surgery, because it can be a sign of the poor outcome. So we can see that we didn't find any specific combination of the techniques that can help us find the best pipeline for surgical in the case of the MRI negative. So there is no the best solution in any case. Considering just the concordance between the surgical planning, adding for all the patients, it's not useful. It is useful, of course, considering this subgroup of patients. So it could be helpful in case there is a very difficult case to consider, and in this case you can use more than one technique, and it can be helpful to predict a good outcome. And this is what we studied about the DESIRE project, and we have the other second that we are very interested now, and they are the mesial temporal lobe epilepsies. And in this case, it's very specific because they are very difficult to lateralize. Because of course EEG and MAG have difficulties to find the best solution, the affected lobe. In this case, we recorded with the foramen ovale electrodes, which are electrodes that are placed inside the nose, which read and reach the mesial regions of the brain. So we are near the hippocampus and the mesial temporal regions. And they were very good to record very similar. They were very good to record the spikes. So in this case, they are used to decide which side to consider, left or right. And of course, they are recording the ictal period to decide. We considered, of course, in this case, it was very useful to consider simultaneously record the EG, MAG, and see what can we see considering what we see inside, in particular this mesial temporal activity. As I show you on the right, you can see where are they placed. So very in the mesial region, not near the hippocampus, but very near. And in this example, as you can see, I set the starting point to the spike, but on the EEG and MEG, it is hard to see something. So at the first step, with this, of course, it seems very difficult. So the second step, we try to explore if the hippocampus or mesial temporal rhythm can be at least if there is any kind of information that I can reach in some way. And of course, it always shows us that using a better modelization, a better source, it can detect something. They already tried to do with hippocampus and simultaneous stereo EEG and MEG. There is something, but of course we have a very low signal to noise ratio, so it's very difficult to find something and to find. So as the simplest thing that we can do is to average the MEG channels on the, of course, FOA spikes. So average all the sources that we find timing to the FOA spikes and try to find the best solution. And we saw that averaging the sources of the single sources using models more than just the BEM, we could find, of course, that the spikes originates for the mesial region near the hippocampus. And it can show, in this case, that there is an information, but it is well hidden. So at the second step, what can we do? We try to reconstruct with beamformer something to see, of course, with trying to find there is a chance to see something. At least in this case, we had the simultaneous recording, so it can be useful. But as you can see, I show you the FOA, so foramen lactate, what can be seen inside and what can be seen outside. So on the virtual electrodes, we barely see something. We see something, the slow activity, it can be, of course, seen. But of course, if you're trying to see the spikes, as you can see inside, it's very difficult. So trying to reconstruct signals and trying to find the spikes the same as the FOI, it is not the best solution to go further. So of course, our hypothesis is that, of course, you can try the better solution, use the FEM models, use more particular advanced source modelization. But of course, there is probably something more that in the clinical use, I'm not talking about mathematical, but in clinical use that will help to see, help to define what is the affected hemisphere. And brain connectivity could be something that, of course, can be considered, because even if I do not see the hippocampus mesial temporal region, the brain connectivity can be useful in case, because of course we have a brain network that is altered and maybe can give us some kind of information. So we are now, unfortunately, I had just 5 patients with foramen ovale. So these are the first steps that I'm trying to see, just the classical reconstruction and with using the atlas and trying to find the connectivity, whole brain connectivity. And in this case, I used the imaging coherence. And because I tried to find with the graph theory something, but I have a very low number of patients, I included also the temporal Brighton patients with well-defined hemisphere, and to see what if there is if they are showed a similar. Of course, I forgot to tell that after they do the foramen ovale, at the end I know the right side from the after the FOEC monitoring, and at the end it was telling me that the ictal creases were also recorded at the right on the left. So I know at the end of the this dissertation that which is the right and which is the end. I did not, in this case, I just already separated. I decided to do just the simplest thing, so to consider separate the ipsilateral interhemispheric connections in the separates, in this case, the interhemispheric connections and intrahemispheric connections, and to see if there is some kind of difference between the affected hemisphere or the non-affected. If I can define distinguish the right temporal epilepsy from the left in the foramen ovale patients, and also of course in temporal, classical temporal. From this first evaluation, the only thing that I could find that the right temporal patients have the higher interhemispheric connections in the beta band compared to the left and the healthy subjects. I could not distinguish, at least with this method, the left patients from the healthy subjects. So this is just the start, the first step that I'm trying to see. I need to have more patients, and of course I need to do a more advanced connectivity studies and apply club theory and classification for this is just the beginning. So this is all that I can tell. And I would like to thank you, my colleagues that are collaborating with me and that helped me a lot. So in particular, my magnetoencephalography lab, the epilepsy unit, and all the people that were involved in the design project. Thank you very much.
Thank you, Dunja. Thank you very much. Very, very interesting talk. Are there questions from the audience? Let me see. Well, in the meantime, I have a question. So I was wondering, because regarding the first part of your presentation, in which you used so many different methods, I was wondering whether you also used simultaneous MEG and EEG recordings, and whether you tried some like fusion imaging, more or less like Giovanni was telling us about earlier.
As we did have the EEG 64 channels, but not for all the patients. So when we so this is the subgroup. In this case, we used just it was not simultaneous for all the 41, but in subgroup we could find. In this case, we used all the separated, of course. In the second step, we could use having the simultaneously EEG and MEG. It maybe can be useful in this case. Yes.
So, but you did some fusion imaging, so combining MEG and EEG data at one time, or you analyzed them separately?
They were analyzed separately and then fused together in the, as you see, as the image. But not, of course, in the calculation. This would be would be the next step, of course.
Okay, thank you. Are there any more questions on Dunja's presentation? Okay, so how many patients do you have more or less per year? Like how long does it take to collect this number of patients?
Depends, because of course they are, if you're trying to separate the temporal patients, you have to wait. So for each, depends if you're asking, you're recording for a task, it is easier than to trying to find epilepsy patient, because they are different one for each other. So in most cases, we collected this 41, but I think because we needed to do all the 4 techniques, so it took time to have also the outcome. In cases, I think at least 2 for temporal patients, we are recording now, maybe 2 a month, just a temporal. If you want to decide,
okay,
per month. If you want to know foramen-ovale, it's less, even less. The problem is that, of course, foramen-ovale is applied when you're not sure about the affected side. So of course, it's not applied for everyone. You need to wait for these special cases. This is why it is so difficult. It takes time to find the number of the available patients. But yet we are working with at least 10, I think we can reach.
So it takes quite a lot of time anyway. There's a question by Sarah.
Yeah.
Sarah, please go ahead. We cannot. I cannot hear you at least. Ah, okay. You're right. Please write. How do you collapse the activity of reconstructed ROI, so reconstructed region of interest?
Sorry, how it collapse, or
how do you collapse in connectivity studies? She's specifying how do you collapse the activity of regions of interest?
Okay, so not the mean, but or the PCA or because of course I know for the orientation that changes. So SFVD and or the PCR, the recommended one. Or you choose to, of course, you choose to use the barycenter. But in this case, I use the SVD. So the most, I think that is one of the used for the each ROI. Yeah.
Okay, so this SVD takes into account the orientation of
some includes of course the check on the orientation. If you use just the mean, of course you know that the nearby are could change the direction, so you have to check for this.
Okay, she has another question, I think, which is what's your feeling about testing different parcellations approaches? Does this change the results, or may this change the results?
I think that, of course, in case of connectivity, everything it has to be tested, because you can have different results, and you have to test also the connectivity indexes. Different, it depends, because of course you have different also information. I mean, I'm not if you study just the marginal query, all the phase-based is different from ISC results. So again, it can change what you are studying, because you are changing. You're studying the power. If you're studying just the phase, and the parcellation on the other side, I would like to use. I mean, as for me, I try to use the different source localization. So different parcellation is always the best results is to try all the possibilities and to see how much it's something that should be studied anyway. You're trying to say the data-based parcellation, or the just IL, sorry, the classical. I cannot hear her, so I'm not seeing she's there.
Yeah. I think she has some problem with the
okay,
with the audio device.
Okay. Yeah, I tried.
But can you see the chat? She's saying also some MEG-informed parcellations. I assume she's talking about like lead field informed parcellations. Yeah.
Okay. No, in case, yeah. Okay.
We can talk about this, she's saying.
We can talk also about the different modelization, the forward models that we have a lot of time. Yeah.
As soon as I can make the microphone work, she's saying. Okay.
No, not now.
Not now. But maybe also in the breakout room, maybe later. Okay, thank you, Dunja. I think.
Okay, thank you very much.
Thank you very much. I think it's time to go to the next speaker.